Okay, this is our fourth video in our series on dealing with comparing two samples as it relates to a measurement of central tendency. And now we're going to be focusing on the nonparametric equivalent to t-test. So if you're going to be doing a t-test on a population that's skewed, like something like household income, maybe doing a t-test isn't the most appropriate thing. Maybe it's better to do a nonparametric equivalent. So nonparametric test, nonparametric, refers to a type of test for data that do not fit the parametric distribution, so that do not fit the normal distribution. This is non-normal distributions. So we focus more on medians and ranks and so forth. So right here in that online textbook, the PDF version, if you want to read more about the Mann-Whitney test, particularly the Wilcoxon rank sum test, you can do so. And 308, it also gives you some advantages and disadvantages of non-parametric methods. So we're going to focus on how to compare non-parametric distributions. So when data do not fit the normal distribution, we tend to not want to focus on the average. We want to focus on maybe a median or focus on a ranking of the data where no single data point gets greater leverage. So how do we test? Those should be review. How do we test for whether or not a distribution is normal or not? For smaller samples, when you've got less than a couple thousand, maybe a Shapiro-Wilk test would be better. But when you've got larger samples, this, like 3,000 or 4,000 or even more observations, the Shapiro-Francia test is viewed to be appropriate. Some folks will actually set the p-values to do normal statistics at p-values that are above 0.15. So when you'd have p-values below 0.15, they would say that the data appear to be not normal. Others are okay with using a more traditional p-value of 0.05. So for simplicity's sake, for this course, we can use p is less than 0.05 because that's what we did earlier. Although personally in my professional work, I tend to use p-values less than 0.15. So for our county household data set, or our county data set for the country, we had data on household income. And if we divide our data by creating a category for rural, and for rural here, coded as 1, and non-rural coded as 0, and this is from previous slides or previous videos, we said that this was 90% or more rural, or greater than 90% rural, and this was 90% or less. So these are the counties that are suburban or not heavily rural, maybe mixed land use. These counties rural, they're dominantly rural counties, not much urban area in them. These represent 753 counties. These ones with 90% or less rural represent 2,381 observations. And with regards to income, when we do by rural, we get the Shapiro-Wilk test result, or Shapiro-Francia results. We see these really low p-values. So this is the p-value, and when you see the p-value of 0.00001, we know that our data are highly, highly, highly likely to not be normal. They are statistically different from the normal distribution at p is less than 0.05, or at alpha level of 0.05. So we've got non-normal data for income, which is not uncommon. If you were to plot it using our Q-norm plot, we get this plot here, we can see the data do not seem to follow the normal distribution line, or the inverse of the normal distribution line. So again, visually, it doesn't look normal. Here, it's skewed. We have, this is, the mode here, but we have all this data here to the right side of our most frequent observations. So this data set is skewed. And when we do a t-test, we focus on means. And that's a problem because the mean in skewed data may not be the best measure of central tendency. So imagine you've got a population with tremendous disparity in wealth. Most families make $20,000, $24,000, $30,000, $24,000, $33,000, $40,000, $19,000, and $38,000. But you've got one family that makes $1.2 million. So when you do the average for that, it's going to be skewed. So if we were to do the average for that, the mean for this community is $158,667. So if you had a group of 9 counties in an area and you said, oh, those counties have a mean income of 158,000 or 159,000, people would say, well, that's not very representative. It's skewed because of this 1.2 million in that one particular county. Or if you're talking about families, about 9 families, you'd say, oh, this is not accurate for those 9 families. 8 families are not, making a lot of money, and one family is making a whole lot of money. So it's skewed by that one result. So if we do the median, and we were to rank them from lowest to highest, we'd say the median for these counties is $33,000. And we have one outlier of 1.2 million. So the median kind of takes away, this is maybe the poorest county right here, 19,000. It's kind of ranked number 1. It's the poorest, or ranked number 9, depending on the way you want to look at it. And then you've got the county at 20,000. That's maybe ranked number 8. Then these are ranked at maybe number 7 and 6. These are ranked at 5, 4, 3, 2, and then that's ranked number 1. But the median is 30,000. You can order them like so, as I just stated. So you can order them from lowest to highest. And in nonparametric statistics, that's part of what happens. The software does this for you. So for a practical example, you may be interested in asking yourself, is there a difference in incomes between rural American counties and the rest of America, the counties that are less than or equal to 90% rural? You do the Shapiro-Francia test, which we just did, and the p-value is really low. So the preferred statistical test would be to do the Mann-Whitney test. Now, Stata calls it the Wilcoxon rank sum test. These are the same thing. You'll see it called both in literature, like the scientific papers. I was always brought up calling it the Mann-Whitney test, but Stata does call it the Wilcoxon rank sum test. And this is preferred over the t-test when the data are skewed, when the data do not fit the normal distribution. So in Stata, there are 3,000 some odd counties. These counties here were coded as 0, and the list goes on, and then you can imagine in Stata, as you go way, way, way down, you'll start seeing 1s and household income data for those. Now, when we go to our actual data, we see the median for the United States is 47,378 for the non-heavy rural counties. 47,000. The mean for the United States is 49,000. So the rich counties are pulling the average up in non-rural America. In rural America, the rich aren't pulling it up as much, the rich counties, but 45,000 versus 44,000. So this is the median, that's the mean. When we do a t-test, if you were to do one, you could do the point and click method, or you could just enter this in manually in the Stata. You do the t-test on household income by rural, and we assume unequal variance, and it's comparing these two means, this mean versus that mean. The mean of group 0, the non-heavy rural, versus the heavy rural counties. And we're comparing this, and according to the t-test, there is a statistically significant difference at the alpha equals 0.05 level. So yes, these are statistically different. P is less than 0.05. So yes, there is a significant difference between group 1 and group 0, or rural, heavy rural versus the non-heavy rural. For the Mann-Whitney test, you do something very similar, summary, table, and test from the statistics command in Stata are at the top there on the menu. We then go down to not classical tests, but we go to nonparametric test of hypotheses. And then if you want to do the Mann-Whitney test, you select Wilcoxon rank sum test. So you click on that, and then you get this screen, this little box, and the variable that we're interested in would be household income, and the group would be rural. Now, if you're interested in doing a left-tail test or right-tail test, you could do that, but we're not interested in that. So just interested in household income by rural or not rural, and whether or not there is a difference. So it does this test, and when it does it, Stata says 2 sample Wilcoxon rank sum, and it calls it Mann-Whitney test. And it's got 2,381 observations for non-heavy rural, 753 observations for heavy rural counties, and then it generates these rank sums of what we actually have, and then this is what we would expect. We would expect these rank sums if nothing was going on, if there was no difference in the actual populations. We get a p-value of 0.0000, so you should be immediately thinking p less than 0.05, significant difference from something. So the rank sum for the heavy rural counties is significantly different than the rank sum for the expected amount for the non-heavy rural counties. There's a significant difference according to the Mann-Whitney test. So the t-test and Mann-Whitney test in this case come to the same conclusion. And as you get larger and larger populations, in many cases that will hold up over time. But in general, it's still a good rule of thumb that when you have non-normal data, to use a focus on the ranks rather than a focus on the averages. If you want to learn more about how the Mann-Whitney test works and then see another practical example, we're going to have another set of slides on that here following this video. So thank you and enjoy.